this morning. Right. Okay. I think I'm hearing some feedback. Okay, so we'll be going through functions today, ne? And I want you to just stay with me. I'm just going to make a brief introduction, sorry, on functions, and just talk a little bit about them, and then let's go into past exam questions. All right. So if you have any challenges, please let me know or stop me anytime. Okay, and we are recording these sessions so that if you should need to go through, the material once again, you're more than welcome to ask for the link. Okay, right, now let's go right into our lesson. Okay, so we will be looking at, okay, let's allow 30 in. Okay, so we're looking at functions, right? Now remember, we've got different types of functions. Of course, we've got the straight line function, which we probably actually already know by now, where we've got y is equals to mx plus c. We know that the m value, the coefficient of x, always stands for the gradient, okay? And the c value always stands for the y-intercept, okay? Right, and in this case, in terms of our gradient, we know that we can always get the gradient when we've got 2 points by using the formula y2 minus y1 rather, divided by x2 minus x1. Okay, and of course, if we wanted to find, the c value, we always just substitute whatever point that we have. Okay, right. Quickly continuing. Then we've got the parabola. Okay, and I'm going to be really quick about this. Okay, so there are three basic ways, or there are three functions or ways in which they can give us the function of a parabola. The first one is in the standard form y is equal to ax squared plus bx plus c. Now, the advantage of this is that we can always just simply know what the value of the y-intercept is, okay, where the graph cuts through the y-axis. So this would be c and 0. So this c value here stands for the y-intercept, okay. The second one is we can be given the parabola in the form a is equals to x minus p squared plus q. Now, I want you to note in this case, it means that here we've got the value of the turning point, okay? So that would mean that the turning point would be at p. Note in this case that the p value changes sign. So if it was minus p, then it becomes plus p, but the q value remains as is, okay? So just for argument's sake, if I've got y is equals to minus x plus 3 squared plus 4, so that would mean therefore that the turning point in this case would therefore be negative 3. Note that it changes sign, and the y value of the turning point would be 4. Okay, please keep that in mind, right? And then the last way in which they give us the equation of the parabola would be a into x minus m, x minus n, where in this case what it simply means is that the advantage is that we would know what our x-intercepts are, okay? In this case, we know that our x-intercepts in this particular case would be m and 0, okay? By the way, sorry, I made a mistake here. I realized when I wrote that. Remember, the y-intercept would be where x is equal to 0. So this would be 0 and c. Okay. Right. So our x-intercept would be m and 0, as well as n and 0. Please note once again that they change sign once they are inside the once they're outside the bracket. Okay, right. So that is what how the cookie crumbles in terms of the parabola. Just a couple of things to note for the straight line. Note that when the gradient or the coefficient of x is positive, in this case, we know that a positive gradient, we use the right-hand tick. We know that this would be a positive gradient. And in this case, for negative gradient, you've got something that looks more or less like this. Okay. So you think about ticking. Okay. This would be the positive gradient. Okay. And of course, I'm not sure if there's anyone who ticks in this manner, but in this case, that would be a negative gradient. And for the parabola, when the value of a, for any of the expressions here, the coefficient of x squared, okay, when that coefficient is greater than 0, then we know that we are looking at a smiling parabola. Okay, so when a is greater than 0, this would be a smiling parabola. And when the coefficient of of a is less than 0, then we are looking at a sad parabola. Okay, please keep that in mind. All right. So sometimes when we've got the standard form y is equal to ax squared, plus bx plus c, to get the turning point or the x value of the turning point, what we normally do is minus b divided by 2a. So it means what I'm going to do is I'm going to take that value there, the coefficient of x, which is that b value, right? Please remember, we put the minus sign first, minus b, right, divided by 2 times the coefficient of x, of x squared rather. So now, obviously, if I want to find the y value of the turning point, what I will do is I substitute the x value that I obtained here into the original equation. Please keep that in mind, okay? Right. Remember, for the x-intercept, I know that if I want to find the x-intercept, I will simply say y is equal to 0, right? But if I want to find the y-intercept, okay, then I know that x is equal to 0, okay? And of course, that's how we work out the value of the turning point, right? Now, let me talk about the hyperbola quickly. Hyperbola. Right, so the hyperbola in this case is a graph. No, so usually we've got the expression a over x minus p plus q. Now, please, I want you to listen very carefully, right? So for the hyperbola, the value of p, now this one shows us what we call the vertical asymptote, okay? So if our a value is greater than 0, okay? Now let's consider where we say p is equals to 0 and q is equals to 0. So it means now you've got y is equals to a over x, okay? So when our value for x is greater than, a rather, is greater than 0, it means this is a hyperbola that will be in the first quadrant, okay? And another one in the third quadrant, okay? Right, because you've got positive and positive values, and here you've got negative and negative values. So in that case, your x is positive, y positive there in the first. You've got both y and x being negative here. So that would be, so this is when a is greater than 0, okay? But in this case, when we've got a that is less than 0 for the hyperbola, then what we find ourselves with is a hyperbola that will be in the second quadrant as well as in the fourth quadrant, okay? Now, this is where the asymptotes come in, right? So if I've got y is equals to a over x minus p plus q. Now, please, I want you to note this. it means this hyperbola has now been shifted. Note very carefully. Né? So it means that my asymptote, okay, I would have an asymptote at P, right? So notice it changes sign. Once it's minus P here, it means that my asymptote would be at positive P. So it means that my vertical asymptote would be at P, but it means that my horizontal asymptote, this one here, would be at y is equal to q. Now, the y value does not change sign, so it means that this would be p and q. So now you are going to draw your hyperbola between your asymptotes. So remember, if your a value is greater than 0, so it means this now becomes your quadrant, okay? And it means that would become your other quadrant, okay? That would be your first and the third quadrant, okay? Between your asymptotes, right? But notice when our a value is less than 0, once again, you've got y is equals to a over x minus p plus q. So in that case, what it simply means is that here's our x and y intercept. But remember, you have your asymptotes, which means it's the points or the lines that the graph never touches. But if your a is less than 0, it means that your asymptotes would now be on the third quadrant, on the second quadrant, as well as on the fourth quadrant. Okay, the fourth quadrant of your, I like to call them shifted axes. Okay, so in a sense, it's almost like you've taken the x and the y axes and you've shifted them, in this case, by p and q. All right. Yeah, so that is how the cookie crumbles. Sorry if this is going to be very quick. I'm trying to get us to do as many questions as possible. So I'm just going to be just touching on this. So, and then we've got the exponential graph, okay? So we've got the exponential graph, okay? Now, in this case, for the exponential graph, I want you to please note that we've got y is equal to a to the x, okay? Now, I'm going to show you how we can shift this, okay? So in this case, what we do for the exponential graph, I want you to note that we've got a graph that looks something like this, and it just keeps increasing. So what it does is that it will cross the line, the y-axis, at the point 0, where x is 0 and y is 1. But remember, the point is simple. Why does that happen? It happens because we know that when x is 0, anything to the power 0 is 1. So in this case, a to the power 0 will give us 1, and that's why it will pass through 1 there. Okay, now, just a very important thing for you to note. Sometimes we can express the graph as y is equal to a minus x, a reflection. We'll talk about reflections a little bit later. Right, so a minus x in this case. Now, what would happen if I've got a minus x, something like this? Okay, so what it does, please, I want you to note, this is, if you think about exponents, this would be the same as 1 over a, or rather, let me write it down in full. So this would be a minus 1 into x. So therefore, this is the same as having 1 over a to the power of x. Okay, so all that you are doing in this case, this is a reflection. Once I change the sign of x, this now becomes the reflection around the y-axis. So it means that your graph would now be looking something like this. Okay, so that would be the graph that you have there. Okay, so No, actually, I am actually incorrect. It would be a graph that looks something like this. Let me just draw it in another color. It would be a graph that looks something like this. Okay. Right. So it would be a reflection around the y-axis. Okay. Whereas if I change the sign, right, and I say y, okay, let me write that down. If I have y is equal to, in fact, let me write it in a different color. Y is equal to minus a to the power x. So in this case, because of that minus sign, that graph now would be a graph that goes more or less in that direction. Okay, so please just make sure you note those changes. Again, for the exponential graph, you can have a shift. Okay, y is equals to a into x minus p, okay, plus q. So note this would be a horizontal shift. So once you say x minus p, means you're taking the original graph, okay, you remember what it looks like, and you are shifting it p units to the right. Now notice when it says minus, you are shifting it to the right, to the positive side. When it says plus, you are shifting it to the left. Né? Okay, and then q, in this case, it means that you are shifting it either up or down. So when q is positive, it means that you are taking it upwards. So in that case, you'd have a graph that is somewhere there. Okay, so that would impose, or that would mean that it is a shift. Now, what I want you to notice is that the y, or rather the x-intercept, is our asymptote for the normal graph. So when there's a q value here, so that now becomes your horizontal asymptote. Okay, right. In fact, you know what I want us to do? Let's go into applications. Okay, for me, I think if we can try and cover as much ground in terms of doing applications, that would be even better. Okay, right. Let's go into the first graph. Now, they say sketched below are the graphs of minus 2x squared. Okay, let me just lessen the brightness there. Okay, it's the graph of minus 2x squared plus 4x plus 16. And you've got g of x, which is 2x plus 4. Okay. Now, they say at A and B are the x-intercepts, all right? And C is the turning point of F. Right, now let's talk. So they say to us, calculate the coordinates of A and B. So how will we get the coordinates of A and B? Right? So what we're going to do is to get the coordinates of A and B, we take the original equation, right? What happens at A and B? I know those are my x-intercepts of the graph, okay? So I'm going to make sure that for my x-intercepts, I am going to take those x-intercepts. So it means this is where y is equal to 0. It means that if I take f of x is equal to minus 2x squared plus 4x plus 16, this is equal to 0. So let's solve for that. Okay. So that's minus 2x squared plus 4x plus 16 is equal to 0. So let's multiply everything, or rather, let's divide everything by negative 2, right? So if I divide by negative 2, I'm left with, okay, if I divide by negative 2 there, divide by negative 2, divide by negative 2. And of course, what you do on the left, you do on the right. So what will I have? Remember, I'll have x squared there. 4 divided by negative 2, that becomes minus 2x. 16 divided by negative 2 changes sign. That becomes minus 8 in this case. So How do we factorize this? What are the factors of 8 such that when I subtract them, they give me 2? Okay, I'm sure you already see that. We're going to have x and x there. We're going to have 4 and 2, right? So if the sign is negative here, it tells us that the signs inside the brackets are not the same, right? So in this case, where do we take, so it means this will be minus and that will be plus, so that the sign of the bigger product, 4x and 2x, we will take the sign of the bigger product and 4x will be that bigger product. So it means that we've got x is equal to 4 or x is equal to negative 2. Now, that means if I look at this, my a value would be minus 2 and 0, and my b value would be 4 and 0. All right, I hope that we are okay with that. All right, now let's say, so now they say to us, determine the coordinates of C, the turning point of F. So we want the turning point. How do we get the turning point? Remember, we take the original equation. We said that's minus 2x squared plus 4x plus 16, right? To get the x value of our turning point, what do we say? Minus b over 2a, right? Now I'm going to show you something else. Okay, another way of getting those the x value of the turning point. So that's minus b over 2a. So that would be minus, our b value is 4, okay, divided by 2 times our a value is negative 2. There's our a value there, right? So you've got negative 4 divided by negative 4. That means that your x value of your turning point is 1, okay? But remember, now we want the y value. So now we're going to take f of 1, okay? So we're going to take the original equation, substitute the x value there. That's minus 2 into 1 squared plus 4 times 1 plus 16, okay? Now, if you look at that, this is going to give us negative 2 plus 4 plus 16, okay? That's going to be 20 minus 2, and that should give us 18. So it means that our values, the coordinates of C, are going to be 1 and 18. And please, every time that you are doing that, always make it a point that it makes sense. In case that, say for argument's sake, you got minus 18. It wouldn't make sense for the graph to be drawn in this way, but for you to have a negative y value there, right? So that's going to be 1 and 18. Now, please let me show you another way of calculating that x-intercept. Not x-intercept, rather, the x value of your turning point. Now, remember, we often call the turning point your axis of symmetry. So what this means is that your graph is a reflection of itself around that turning point. So it means it's sort of the halfway mark between your graph, okay, in your graph. So remember, we got the value x is 2 here, we got the value x is 4. So what you can do is, to get the turning point, the x value of your turning point, you take this value plus that value, you divide by 2. So that would be minus 2 plus 4 divided by 2. Now, remember, minus 2 plus 4, that will be 2. 2 divided by 2, that will give us 1. Do you see that we get the same value? Right? So x value of the turning point. And of course, to get the y value, in this case, you can actually get, just use the original equation, just substitute that point, just like we did in the previous one. All right, now, ladies, are we okay? Are there any questions?
So can you please re-explain 5.2, the second part?
The second part, to get the y value of the turning point.
Yes, sir.
Okay, so what I did was, okay, so you understood how to get the x value of the turning point.
Yes, sir.
Okay, right. So remember we took minus b over 2a, or alternatively, as I did show you just now, that you can just take the it's basically the mean value between your x-intercepts. Okay, so it means it's the halfway mark between those two values there. Now, to get the y value of the turning point, all I did was to take the x value and substitute it back into the original equation. Okay, right? I took x is equals to 1, which is the x value of your turning point, and I substituted that value into the original equation. So note that was minus 2. Everywhere I see x, I'm going to substitute 1. So that's 1 squared plus 4 times x. Our x is 1 plus 16. And in this case, of course, we got 18 as our final answer. Is it making sense, Ashley?
Yes, sir.
Yeah. Please let me know if please stop me anytime, né? Because remember these sessions are meant strictly for you, so that you guys can benefit maximally out of them. So if I'm doing something that does not really make sense, please let me know. Okay. Right now, now remember, so they say find the range of f. What is the range? It's where the graph exists in the in the y's, right? Now think about it. The parabola would continue and continue all the way up until negative infinity, right? But if you go up from negative infinity, what's the maximum point that it would go? It would be that y value there, 18. Okay. Um, so in this case, what would be our range? Our range would be y is an element of minus infinity, right? Up until it gets to the maximum point. It does not exist beyond y is equal to 18. Sorry. By the way, you need to use a square bracket there because it exists at 18. Okay. Another way of writing that down, you can say y is less than or equal to 18. Okay, so y exists for all values from 18 going down. Okay, the graph, the graph exists in the y axis. Are we together?
Yes, sir.
Okay. I just wanted us to do something. I know it's not in the question here. Okay. Now, there are 2 points of intersection between the graph of f of x and g of x. Okay. Is it possible for you to find for me this point here? Let's call this point, let's see, we've got A, B, C. Let's call this point D. Okay. Right. How can we find point D? Anyone? Okay. Right. What's happening at point D? Well, the two graphs are meeting at that point. Do you agree? It means that both the x values, they share a common x value and they share a common y value. So now what we would have to do is to say, look, if we are looking for the value of d, now remember, we said f of x is, we said that was minus 2x squared plus 4x plus 16, okay? And then g of x, I believe was 2x plus 4. That's 2x plus 4. Okay. Now, we said what's happening at that point D? It means that both of the graphs are meeting at that point, right? Now, then it means what's happening? It means f of x is equal to g of x at that point, right? So as a result, it means that f of x, which is minus 2x squared minus 4x plus 16 is equal to 2x plus 4. Now let's try and solve that quickly. We've got minus 2x squared. Okay, you've got, if I take this to the other side, it becomes minus 2x. So you'd have minus 4x minus 2x. Then plus 16. If I take this to the other side, minus 4. And this would be equal to 0, right? So we'd have minus 2x squared minus, so remember, we've got negative and negative, so minus 4x, sorry, minus 4x minus 2x, that will give us minus 6x, negative 6x, okay? 16 minus 4, positive 16 minus 4, that would give us plus 12, okay? The signs, if the signs are not the same, we subtract and we keep the sign of the bigger number. Okay, right. So in this case, we've got positive 12. Right, we can divide this. I'm sure you can see this. We can divide this by negative 2 again. Okay, so divide everything by negative 2. I've got x squared, and negative 6 divided by negative 2 gives us positive 3. Positive 12 divided by negative 2, that would give us negative 6. Okay, right. Now, what are the factors of 6 such that when I subtract them, they give me 3? You'll see that there's none. Okay, so even if you took 3 and 2, okay, or 6 and 1, it can't be that when you subtract them, they give you 6. So what we're going to do is use our quadratic formula, okay? So we're going to say x is equal to minus b plus minus the square root of b squared minus 4ac, okay, divided by 2a. Now what I normally do in my case, I actually refer to this guy here as square root of delta. So what I do, I calculate delta separately. That's b squared minus 4ac. That is going to become, our b value is 3, minus 4 times our a value is 1, and our c value is negative 6. Okay, so now you've got 9 and minus 6, and minus 4 times minus 6 is going to be 24, positive 24 times 1, so that's going to be plus 24. And so as a result, it means that we've got 33 as our square root value. Right, now please, I want you to note. So now I'm going to say this is minus b plus minus square root of delta over 2a. That would be minus b. Remember, we said our b value is 3 plus minus the square root of our delta value was 33 divided by 2 times our a value was 1. Okay, so that would be 2 times 1, which is 2. Okay, now let's find the values there. Okay, right. So that's minus 3 plus square root of 33 over 2, and minus 3 minus square root of 33 over 2. Okay. Get a value of minus 1.37. Did I not make a mistake somewhere?
Sir, I think for f of x, you said negative 2x
Oh man,
squared minus 4x and it's plus.
I said?
For f of x, you said negative 2x squared minus 4x and it's plus 4x.
Yeah. Okay, so that's where I made. Okay, so that was supposed to be plus, ne? Okay, so that made that entire calculation incorrect. Please, when you see me making a mistake, please stop me. Yeah, because I can see that the reason why I could see that that answer is incorrect is one of the values that we're supposed to get. Remember that the two graphs are equal at 2 points, right? At A, so it means one of the solutions that we're supposed to get was minus 2. So I could see that, Norman, none of those solutions were minus 2. Because remember, they are equal at 2 points. They're equal at A and at that point that we called D, right? So we had, okay, so I said f of x is, yeah, so I see where I actually made an error. So that should have been plus 4x, ne? So that would be minus 2x squared plus 4x minus 2x. So that would be plus 2x, okay? And then 16 minus 4, still that would become 12. Okay, and this would be equal to 0. And if we divide by negative 2, we'll be left with x squared minus x minus 6. Correct? Are we okay with that?
Yes, sir.
All right. Ashley?
Yes, sir.
Okay. Ntati, are you also okay? Okay. Right. So in this case, I'm just going to so we can actually factorize this. We didn't have to go the whole 9 yards. So this would be factors of 6, such that when I subtract them, they give me 1. That would be 3 and 2, isn't it? Okay. So it means my signs are not the same. So it means this would be minus 3x, and that would be plus 2x. All right, guys, is there anyone who has an issue with factorization? Would you like for me to take time to teach you this separately? It is quite an important operation in maths because it lends itself in many other sections. So in this case, what do we have? We've got x is equal to 3 or x is equal to minus 2. So do you see that x is minus 2 that I was talking about, right? Which point is that? It's that point A there, all right? Because we know the two graphs are equal at that point. Okay, so meaning that at D, we know that the x value at D should be x is equal to 3. But now, how do I find the y value at D? I can take this x value and substitute it in any of the two equations, whether the equation of f of x or the equation of g of x. I'm going to use g of x because it's much easier. So it means g of 3 is 2 times 3 plus 4. So in this case, 2 times 3, that's going to be 6 plus 4, that's going to become 10. Okay, so it means that you've got your x value, rather your y value at D is 10. So in this case, it means that D has got the coordinates 3 and 10. Are you guys with me so far? Right.
Yes.
I want you to do something for me very quickly. All right. I would like for you to calculate for me, let's say, the distance. Okay, let me just make a point there. Let's call that point E. Okay. Can you please calculate the distance CE for me? How long would be the distance CE? Would we know how to go about that?
Sir,
Yebo.
would it be possible to use the distance formula without the second point coordinates? 'Cause
The
E doesn't
distance.
include-
Tell me what you mean by that.
There's no numbers for E. There's no X and Y for E.
Mm-hmm. So, do you agree with me, Ashley, that E would have a common X value with C?
Yes, sir.
Okay. So, what would be the X value at E? It would be 1, right?
Yes, sir.
But what we don't know would be the Y value at E. But we can easily get that because this is where we know the equation of the straight line. So it means we'd need to find G at 1. That would be 2 times 1 plus 4. So now this would be 2 times 1, which is 2, plus 4, that would give us 6. So this means now E is the point 1 and 6. Now remember, the x value does not change, right? Because it's 1 and 1 there. So how can we now obtain the distance CE, right? The distance CE would be the difference between the y values. So I would say, well, this is 18 minus the y value there. We said it's 6. So it means that CE would be equal to 18 minus 6, and that would give me 12 units. Does that make sense? All right. Or
Yes,
even if I
sir.
were to look at the distance, let's call this GH, right? Again, what would be my y value what would be my y-intercept of this graph? You can already see, I know what my y-intercept will be. It will be 16. So it means the x value is 16. The y value is 16 over there. All right. But what would be my my y-intercept for the straight line? It would be 4. So this value here would be 4, right? So if I wanted to calculate GH, again, this would be 16 minus 4. And so in that case, it would be 12. Okay, once again. Are we good? Ladies, are we okay?
Yes, sir.
All right, beautiful stuff. So what I'm going to do now is I just want us to take another question. In this case, I think I want us to take something that has a hyperbola in it. Okay, let's take this one. Yeah. All right. Now, we're given a hyperbola. Okay. So they say the sketch shows the graph of f of x, which is minus 9 over x minus 1 minus 2. Now, once again, ladies, please remember this. Remember this. Okay. The moment I am given a graph of the hyperbola, a hyperbola equation, rather, remember I said to you, these x values that we are given there, okay, show us, in this case, our asymptotes. Okay, I'm just trying to move this around. It seems to be misbehaving. Okay, there we go. Right. So that should be the values of our asymptote. So it means our vertical asymptote is at x is equal to 1. So it means this guy here is x is equal to 1. So it means this x value is 1 there, right? And then the y value, remember we said it changes sign. You remember that, ne? For the x value. So if it's minus 1, then it becomes positive 1. But for the y value, you take it as it is. So in this case, it means this horizontal asymptote here is at y is equal to 2. Okay. Right. So meaning you're going to have, and there's something I just want to say about the hyperbola. So this point of intersection here would be the point 2, x is equals to 1 and y is negative 2. Okay, so that point A there, right? Now, they say write down the coordinates of A. So we've just written them down. The coordinates of A are going to be 1 and negative 2. Okay. Are we good, ladies?
Yes, sir.
All right. Now on the next one, now they say to us, determine the coordinates of the x and y intercept of the graph of f. So what are we going to do? We are going to make sure that we make x equal to 0 for the x-intercept. This is where x is equal to 0. So let's find y equal to 0 rather. For the x-intercept, we know that y is equal to 0. So it means that I'm going to say the graph of minus 9 over x minus 1 minus 2 is equal to 0. All right, let's try and work that out. So this is simply going to be minus 9 over x minus 1 is equal to 2. So I took the 2 to the other side, okay? And then what do? I cross multiply. So remember 2 is the same as 2 over 1, okay? So cross multiply. So I've got 2 into x minus 1, right? So this multiplied by that would be equal to this multiplied by that. So minus 9 is equal to negative 9 times 1. That will give me negative 9. Okay, so as a result, I will have 2x minus 2, okay, is equal to negative 9. So 2x, if I take this to the other side, it becomes positive. So minus 9 plus 2 will give me negative 7. Divide both sides by 2. And I get x is negative 7 over 2. Okay, so it means that my x-intercept, I hope that is not too clumsy. Are you guys able to see it?
Yes, sir.
Okay, so I'm just trying to write that a little bit more neatly as well. So what we said was at the x-intercept, we know y is equal to 0. So we started with minus 9 over x plus x minus 1, right? Minus 2, which was equal to 0. And then all we did was to take minus 9 over x minus 9, x minus 1 equal to 2. And then we cross multiplied in that case. All right, and then for the, now this is for the x-intercept. It means for our x-intercept, we know we are going to have x-intercept at negative 7 over 2, which is this point here, right? So that's going to be minus 3 over 2 and 0. Okay, right, now let's find the y-intercept. So this is where x is equal to 0. So this is f of 0. This is the y-intercept. We know x is equal to 0. So f of 0 is minus 9 over 0 minus 1 minus 2. Okay, so we've got, in this case, negative 9 divided by negative 1. That would give us positive 9 minus 2. And in this case, that would give us 9 minus 2 would be, in this case, 7, positive 7. Ne? So this means that our y-intercept would be 7 and 0. And it should make sense. Right, when you look at it, this should be positive y value. So this should be 7 and 0. Okay. Right, are we good, ladies?
Yes, sir.
Okay. Right. Now, they say to you, write down the equation of the axes of symmetry that has a negative gradient. Now, this is the part I wanted to tell you about when it comes to the hyperbola. Ooh, I just made a mess, man. Actually, I should have erased that part. So it's going to save it because I didn't remove it before. Okay, so the hyperbola, please, I want you to remember this, has got two axes of symmetry. Okay, I'm going to draw them in different colors. So it has an axis of symmetry. Yeah, let me do this. Okay. So it has an axis of symmetry that has a positive gradient. So meaning at that red line, if I were to fold it around that line, it would actually have, the two graphs would solely lie on top of each other. But similarly, it also has an axis of symmetry that has a negative gradient like that. Okay? So again, it means if I were to fold it around those lines, in this case, they would actually lie directly on top of each other. Okay? Now, so the first axis of symmetry, the red one, okay, would be the line y is equal to x plus p, where p is a value. To get the value of p, we can just substitute that point there, the point of intersection of your asymptotes. Okay? And then for the blue graph, it's y is equal to minus x, plus q, right? And to get the value of q, once again, you would take the axis, the point of intersection of those asymptotes. So now, I'm going to write that down. They say write down the equation of the axis of symmetry, right? That is a negative gradient. So it means they are talking about y is equal to minus x plus q, right? So now, all I'm simply going to do, I'm going to substitute the point A. But remember the point A, when x is 1, y is minus 2. So that would be minus 1 plus q. And so in this case, what you would have there is, if I take that to the other side, you'd have minus 2 plus 1. And so q would be equal to minus 1. Okay, so that means that your equation would be minus x minus 1. Okay, right. Are we good, ladies? Okay, are we okay?
Yes, sir.
Yes. Do you have a question?
No, sir.
Okay, beautiful stuff. All right, so just remember that about the hyperbola. Ne? So remember that the hyperbola every single time. So if it's a 1, let's say you're given a hyperbola 3 over x, right? So the a value is positive. So it means it would exist in the first quadrant as well as in the third quadrant. Now, what would be the axis of symmetry for that hyperbola, right? So in that case, it would be the axis of symmetry would be y is equal to minus x, but the other axis of symmetry to be y is equal to x. All right, those are your two axes of symmetry. So this would be y is equal to x. All right, and the reason why it's y is equal to x is because it passes through the point 0 and 0. Okay, so both your your y-intercept is 0, right? So the other one, the red one, would be y is equal to the red one would be essentially y. Why is this guy misbehaving? Right. So this one, the red one would be y. I don't know why this thing is. Okay. Yeah. Anyway, I'm trying to erase this. Right. So this would be the point y is equal to. Yeah, man. I'm not too sure why this thing is misbehaving like this. So y is equal to minus x, right? Because it's passing through 0 and 0. But remember, once you start having your asymptotes being any value greater than 0, then you just simply substitute the values or the intersection of your asymptotes into the equation. Okay, right. I just want to rush as quickly as we possibly can. All right, let's go to our next question. Right. Right. So in this case, we are looking at composite functions. So this is where we are given two functions in one set of axes. Right. So they say to us the sketch below represents the graphs of two parabolas, f and g. Right. They say the turning point of G is 2 and 9, and the y-intercept of G is 0 and 5. Okay, B and D are the intercepts of, B and D are the intercepts of F and G respectively. Okay, now they say show that G of X is equal to minus x squared plus 4x plus 5. Okay, so G of X, remember, we're looking at this graph over here. How can we show that? Okay. Now, remember you've got the X, you've got your turning point. So what I could do is I could use, you remember the standard form that I showed you, né? In this case, where we've got G of X, rather. G of X is equal to A into X minus P squared plus Q. Do you remember that? Okay. We said, what does the P and Q represent? It represents the X and the Y value of the turning point respectively, right? So I can say this is A into, what's my turning point for G, right? I have X minus 2. There's my turning value of the turning point. And remember, we said it changes sign inside the bracket. So that would be X minus 2 squared plus the Y value of the turning point is 9. Okay. Now, all that's left for us to do is to find the A value, right? And how am I going to find that A value? What I'm going to do is just substitute the other point that I know about G. Okay. So now, to get the A value, I can substitute the point 0 and 5. So it means where X is 0, Y is equals to 5. So I'll have A is 0 minus 2 squared plus 9, and this is equal to 5. Now, 0 minus 2 is negative 2. Negative 2 squared, that's 4. So I've got 4a, right? If I take the 9 to the other side, that becomes 5 minus 9, and that would give me minus 4. Okay? Right? And in this case, what do? Divide both sides by 4. Okay, and so the value of A, I'm going to write it there. The value of A is -1. Okay, right. Now, if I wanted to find the full equation, remember I want to write it down in that standard form. So it means that g of x would be equal to our A value is -1. Okay, so that's -1 into x minus 2 squared plus 9. So let's write that one out. So that would be negative. So when I've got x squared, x minus 2 all squared, that will give me x squared minus 4x plus 4, okay, plus 9. Are you guys still with me? Hello?
Yes.
Okay, right. So I've got, remember I haven't multiplied by the negative just yet. So now I'm going to multiply by the negative. So that will be minus x squared plus 4x minus 4 plus 9. Okay, and so that gives us minus x squared plus 4x minus 9 and minus 4 plus 9 will give me plus 5, and that is what they asked us to prove, and so that is the equation. Okay, right, ladies, are you okay?
Yes, sir.
Did we all get that? Right, it's important that we know those the standard format for the parabola, the 3 different standard formats. All right, now let's go to the next question. They say calculate the average gradient between A and C. Okay, now remember when I'm looking at the average gradient between those 2 points, when I take the y2 minus y1 divided by x2 over x1. So I'm going to have the average gradient. Let me just change the color of this thing. The average gradient between A and C would be y2 minus y1 divided by x2 minus x1. Okay, and our y2, let's take the value at C to be our y2, so that would be 9, and y1 would be 5 at A, so that would be 9 minus 5 divided by, when the x value, when the y value is 9, the x value is 2. Okay, so that would be 2 minus 0. Okay, right. So once again, 9 minus 5, that would be 4, right? And divide that by 2, that would simply be 4 divided by 2. So this would be 4 over 2, and this would give us 2. So the average gradient between A and C in this case is 2. All right. The next question. They say to us, calculate the length of BD. Right. Now, we're looking at B. Sorry. So we're looking at that point there, and we're looking at that point there. So that means that we have to find the x values, all right, the x-intercepts rather, for both of the graphs. Okay. Now, you remember for the first graph, f of x, this one here, there's the equation, it was given to us, right? So at the x-intercept, we know y is equal to 0. So it means that I'm going to take f of x, which is half x squared minus 8, right, is equal to 0. So that simply means I'm going to have half of x squared equal to 8. So I can multiply both sides by 2, So that's multiplied by 2 so that I get rid of that. So x squared is equal to 16. So x therefore would be equal to plus or minus 4, taking, right, the square root on both sides. X is equal to plus or minus 4. Please don't forget to say plus or minus. So which means the value at b is minus 4. Okay, so that value there would be negative 4. Right, now what would be the x value at d? Okay, the x-intercept for the value for this guy here, right? Where is y equal to 0? Now I don't know which equation you want to take, whether you want to take this one here. Okay, let's take that one. Okay, and make it equal to 0. So where g of x is equal to 0, so it means I've got minus x squared plus 4x plus 5 is equal to 0. Now, to make things easier for yourself, just multiply everything by negative. So you end up, it changes sign. X squared minus 4x minus 5 is 0. And if we factorize, I'm going to find x and x. Factors of 5. Sorry. So I'm going to find 5 and 1. Okay, so means that would be minus 5x, and that should be positive 1. Sorry about that, ladies. So it means my x-intercept would be x is equals to 5, or x is equal to 1. Right. I'm sure you appreciate the fact that we are meeting virtually, né? Now, I want you to think about it. We're looking for the distance BD. So to find the distance BD, we're looking at that distance between those 2 points there. Okay, I'm just quickly trying to find a way to show it there. Right, so you're looking at between those 2 points there. How far is it? Now think about it. From the origin, you're going 5 units that way. You're going another 4 units that way. What should be the distance? So BD would be 5 minus, so you'd if essentially just take the x values, so it would be x2 minus x1. So in that case it would be 5 minus a minus 4, and in this case what do you get? 9 units. Okay, right, did you get that, ladies?
Yes, sir.
Okay, Bushe? Okay, I wonder if they're still with us. Okay, in this case, just the last few questions. Now they say use the graphs rather to solve for x if f of x is greater than 0. Okay, now the graph of f of x, remember, is this one here. Okay, now where is this graph greater than 0? First of all, we found out that this graph cuts at minus Gonya, what did we find? We found that value to be 5. But what was this value? This value was 4. You remember, ne? We found this to be plus or minus 4. So this value over here is 4, and this is minus 4. Now, they said, where is this graph greater than 0? So where is it positive? It's positive over here. It's positive over there. This is the F graph, right? Now, it would be positive for all values of x from minus infinity all the way up until 4, right? But it would also be positive from 4 till infinity, all the way, sorry, till infinity. So to answer that question, where's the graph of f of x greater than 0? So it would be x is an element of negative infinity till 4, negative 4 rather, and you must include that because they said or equal to 0, right? So that's a square bracket, and from 4 till infinity. Okay, right. Another way of writing this, you can say, well, this is for x should be less than or equal to negative 4, or x is greater than or equal to positive 4. Okay, that's another way of writing the same thing. All right, are we good, ladies? Okay, so this last question, they said f and g are both strictly increasing, where both graphs are strictly increasing. So, so if I look at that, f is increasing, sorry, between from 0 there up until infinity, and g is increasing from negative infinity. So where is it increasing? From negative infinity up until this point here. Okay, it's increasing there, right? So they said, where are the graphs of f and g? So we want where both of them are increasing, not where the one is increasing and the other one is decreasing. So where would that point be? Between those 2 points here, from 0 up until 2. Okay, both of them are increasing between those 2 points. So in this case, yeah, there's no other point, right? So that would be the increasing where x is an element of 0 up until 2. Okay, are we good, ladies? Did that make sense?
Yes, sir.
All right. I think I want us to leave our lesson there. So we will continue, obviously, in our second session. Now, please, I'm asking ladies, on Friday, what I've done is I've asked someone to assist us, with making a presentation for bursaries, as well as making a presentation about applications to universities. There's also someone who will be presenting about, how to, crack it into the, the engineering and the science kind of fields. So I'm going to make this an open invitation. If any of you have got friends that you'd like to invite, you are more than welcome to do so. I will forward the link. You can actually just send that link to as many people as may want to attend. Okay. Yeah, but definitely, I think we are meeting again. I think we're meeting again just after lunch. Just please check if that is so. All right. Okay, guys, I'll see you again. Take a break, and we'll see each other again afterwards. Shop, shop.